Today it's Wednesday, September the 17th, and on this first video we'll show the setup for what will be the medium voltage AC controller demonstration. In this particular setup, we'll use 480 volts AC, not 3.3 kV, but the concept is essentially the same. We have our source, whether it's 480 or 3.3K. Then if we ignore the fuses, we have three pairs of SCRs in anti-parallel so that our output can be 0 to 480, or if we bring in 3.3K, 0 to 3.3K volts AC on the output. Again, three pairs of SCRs in anti-parallel, and what we're doing is we're using our 6100 board to control all six SCRs. And here on this connection diagram E2229, the board will be set up for a 0 to 10. In this particular case, we have a board that is set for 0 to 5 volts, and we're using a potentiometer. We could have used a power supply to bring in that continuous DC signal that will determine what the firing delay angle would be and what ultimately the AC output will be. So I have 480 coming in, and that 480 goes into our SCRs. Then I have the output going in here. We have a 480 volt three-phase motor, and I do have the phase references now because this is 480. Here we have our phase references coming into our board. Now, if this were 3.3 kV, this is where we will use from the three-phase source. We will use the RAM, the attenuator module, to bring the attenuated phases into our board. This particular board, being the analog, not the proposed digital board, but it's again the same concept, has 6 outputs, and these 6 outputs go from a fiber optic transmitters into each one of the 6 inputs of the MVTB6-6 board, which in turn go out and connect to our P1 and P2 on our thyristors. I want to show here really quick that I have my connections made from J1 and J2 that go to the SCRs to the output of the MVTV boards. All right, so here we have what else. So once again, just to summarize, we have our source, 3.3 or 4.480 volts AC, comes into our 3 pairs of SCRs. The input comes in, the output controls our load, which is our motor, and we have the phase references coming into the board. We have the outputs and fiber optic transmitters coming to the input of the MVTV6 board, and the output of each of the pulse modules from the MVTV6-6 board comes into P1 and P2 of our thyristors. Keeping in mind that if this were 3.3 kV, we will need the resistor attenuator modules. Everything else would be the same, and this is once again the way we're going to enable the board, and this is what's going to provide via potentiometer a SIG-high signal, which is a DC continuous signal. We're going to have probably a meter in there just to show what kind of a signal we have. This is the end of this first video.